Hi everyone, I am Princess Mika M. Blanco, and my topic is all about Module 10 Statistical Tools and Analysis of Assessment Data, Measures of Variability, Mean Deviation, Variance, and Standard Deviation. Mean deviation measures the average deviation of the values from the arithmetic mean. It gives equal weight to the deviation of every score in the distribution. When we say mean deviation, it tells us the average distance of each value from the mean of the dataset. Here is the formula of mean deviation for ungrouped data. MD equals the sum of the absolute differences between each value and the mean divided by the number of cases or values, where MD is the mean deviation value, X is individual score, X bar is sample mean, and N is the total number of cases. Steps in solving mean deviation for ungrouped data. Number 1, solve the mean value. Number 2, subtract the mean value from each score. Number 3, take the absolute value of the difference in step 2. And number 4, solve the mean deviation using the formula. Let's look at the example. Example number 1. Find the mean deviation of the scores of 10 students in a mathematics test, given the scores 35, 30, 28, 24, 20, 18, 18, 16, 15, and 10. We use the formula for mean deviation for ungrouped data. MD is equals the sum of the absolute differences between each value and the mean divided by the number of cases or values. To solve the mean deviation for ungrouped data, number 1 is to find the mean. According to the table, the mean is 212 and divided to 10 because 10 is the total number of students in mathematics test. So 212 divided by 10 is equals to 21.2. And then the next step is subtract the mean from each score, take the absolute value and add them all up, then divide by 10. So according to the table, 60.4 is the absolute value. Of course, we divide it to 10. And the answer is 6.04. The mean deviation of the 10 scores of students is 6.04. This means that on the average, the value deviate from the mean of 21.2 is 6.04. Mean deviation for group data. The formula is MD is equals to the sum of class frequency of class mark or midpoint of each category minus mean value divided by total number of cases, where MD is the mean deviation value, F is class frequency, XM is class mark or midpoint of each category, X is mean value, and N is total number of cases. Steps in solving mean deviation for group data. Number 1, solve for the value of the mean. Number 2, subtract the mean value from each midpoint or class mark. Here is example number 2. Value of each find difference. The mean deviation number of the 4, given multiply the absolute value and the corresponding class frequency. Number 5, find the sum of the results in step 4. And number 6, solve for the mean deviation using the formula for group data. To solve the mean deviation for group data, of course, when dealing with group data, we use the midpoint of each class and their frequencies. We follow the same idea. Find how far the midpoints are from the mean, multiply by frequency, and average them out. To solve the mean deviation for group data, number 1, solve for the value of the mean. We get 1,345 in the table, divided by 40 because 40 is the total of n, and the answer is 33.63. After we solve the mean, we solve the mean deviation using the formula for group data. The formula is MD is equals to sum of the absolute differences between each value and the mean divided by the total number of cases. In the table, we get 425.22 divided by 40 because 40 is the total of n, so the answer is 10.63. Analysis. The mean deviation of the 40 scores of students is 10.63. This means that on the average, the value of deviated from the mean of 33.63 is 10.63. Variance is one of the most important measures of variation. It shows variation about the mean. When we say variance, variance is the mean of the square deviations from the mean. Squaring deviations of scores from the mean gives positive squared deviations. There are two types of variance: population variance and sample variance. The formula of population variance is population variance squared is equals the sum of frequency of value minus population squared divided by total number of observations. The formula of sample variance is sample variance squared is equals to the sum of the value of one observation minus the mean value of all observations squared divided by the number of observations minus 1. Steps in solving variance of ungrouped data. Number 1. Solve for the mean value. Number 2. Subtract the mean value from each score. Number 3. Square the difference between the mean and each score. Number 4. Find the sum of the results in step 3. And number 5. Solve for the population variance or sample variance using the formula of ungrouped data. Example number 1. Using the data below, find the variance and standard deviation of the scores of 10 students in the science quiz. To solve the population variance of ungrouped data, we use the formula of population variance. Population variance is equals to the sum of frequency of value minus population squared divided by total number of cases. We get 60.40 from the table mean value. Divide it by 10 because the total number of students in science quiz is 10. So the answer is 6.04. To solve the sample variance of ungrouped data, we use the formula sample variance squared is equals to the sum of the value of one observation minus the mean value of all observations squared divided by the total number of observations minus 1. We get 60.40 from the table and then divided by 9 and the answer is 6.71. Steps in solving the variance of grouped data. Number 1. Solve for the mean value. Number 2. Subtract the mean value from each midpoint or class mark. Number 3. Square the difference between the mean value and the midpoint or class mark. Number 4. Multiply the squared difference and the corresponding class frequency. Number 5. Find the sum of step 4. And number 6. Solve the population variance or sample variance using the formula of grouped data. Example number 2. Score distribution of the test results of 40 students in a Filipino class consisting of 50 items. Solve the variance and standard deviation and interpret the results. To solve the population variance for group data, we use the formula population variance squared is equals to the sum of frequency of nth observation of given data minus population mean squared divided by n. So according to the table, we get 2606.04 divided by 40 because that is the total number of observation. So the answer is 65.16. In sample variance, to solve the sample variance for group data, is we use the formula S squared, or sample variance squared, is equals to the summation of n observation of given data minus sample mean squared divided by n sample size minus 1. So according to the table, 60.04 is the end observation of given data. Of course, we divide it to 39. The answer is 66.83. Standard deviation is the most important measure of variation. It is also known as the square root of the variance. It is the average distance of all the scores that deviates from the mean value. We square the deviation scores around the mean in order to deal with negative numbers. It is a measure of dispersion of the scores around the mean. There are two types of standard deviation. First is population standard deviation. The formula is population standard deviation is equals to square root of sum of x minus population mean squared divided by total population size. The next one is sample standard deviation. The formula is sample standard deviation is equals to the square root of the sum of sample mean minus x bar squared divided by sample size minus 1. Steps in solving standard deviation for ungrouped data. Number 1, solve for the mean value. Number 2, subtract the mean value from each score. Number 3, square the difference between the mean and each score. Number 4, find the sum of step 3. Number 5, solve for the population standard deviation or sample standard deviation using the formula for ungrouped data. Note, if the variance is already solved, take the square root of the variance to get the value of the standard deviation. To solve the population standard deviation of ungrouped data, we use the formula of population standard deviation is equals to square root of summation of individual data values minus population mean squared divided by total number of data points in the population. So here in the example, we have the 60.40 of the sum of squared deviation. We divide it to 10. 10 is the population size, so the answer is 6.04. So we need to get the square root of 6.04, so the answer is 2.46. To solve the sample standard deviation of ungrouped data, we use the formula. The formula is sample standard deviation is equals to the square root of summation of individual data values minus sample mean squared divided by sample size minus 1. So of course, here in our example, 60.40 is the sum of square deviation divided by 9. Why 9? Because 10 is the sample size minus 1. And then, so 60.40 divided by 9, the answer is 6.71. We need to get the square root of 6.71, so the answer is 2.59. Steps in solving the standard deviation of group data. Number 1, solve for the mean value. Number 2, subtract the mean value from each midpoint or class mark. Number 3, square the difference between the mean value and midpoint or class mark. Number 4, multiply the square difference and the corresponding class frequency. Number 5 is find the sum of the results in step 4. And number 6, solve the population standard deviation or sample standard deviation using the formula of group data. To solve the population standard deviation of group data, we used the formula population standard deviation is equals to the square root of summation of frequency of each group of midpoint values of each group minus population mean squared divided by total population size. So here in our example, the sum of squared deviations from the mean weighted by frequency is 2606.4 divided by 40. 40 is the population size. So the answer is 65.16, and we get the square root of 65.16. The answer is 8.07. To solve the sample standard deviation of group data, we use the formula sample standard deviation is equals to the square root of summation of frequency of each group of midpoint values of each group minus sample mean squared divided by sample size minus 1. The sum of squared deviations from the mean weighted by frequency is 2606.4 divided by 39. Why 39? Because the population size is 40 minus 1, so equals 39. The answer is 66.8308. So we get the square root of that, and the answer is 8.18. Interpretation. When the standard deviation value is large, it indicates that scores in a distribution are spread far from the mean value. This means the data points are widely dispersed around the average, rather than clustered close to it. Such distribution is described as heterogeneous, meaning the data has high variability. That's for today, and thank you for listening.